All right, number 29. A photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equation models the number of sheets of paper P remaining in the machine n minutes after the machine started printing? Okay, so we're trying to pick an equation to model this question. So first I think about this, will this be a linear equation or would this be an exponential equation? Okay, so this is a little bit tricky because seems like we have like a percentage, right? It says after 20 minutes, we're using 30% of the paper. And a lot of time you have a percent change, right? It's a percent increase, percent decrease. That will give us an exponential model, okay? Because if we're increasing or decreasing at the percentage, right, then it's a constant ratio that we're multiplying, right, each time. But then for this question, it's a little bit tricky because although we do have that percent there, it's not talking about the rate of the printing. Okay, so the 30%, it just says after 20 minutes, we're using 30% of the paper. So that's the total amount of paper that we use, right? It's not the speed or the rate that the copier operates. Okay, and then here in the previous sentence here, it says the machines are large enough and copied at a constant rate. Okay, so I have to look for the rate. Okay, so the constant rate means we're adding or subtracting the same number each time, right? Okay, so the rate stays a constant, right? So the thing about this is a copy machine, when it copies, right? So it goes page by page, and then usually it doesn't speed up or slow down as it do the copying, right? So it's the same rate. Okay, so we're just using paper as we go, but the copying process doesn't speed up or slow down, right? So for this one, it's actually a linear model. Okay, it's not exponential, it's a linear model because it says constant rate. So we should have a same slope, right? Okay, so then we can eliminate C and D because these two are exponential because yeah, I'm in the exponent. Okay, so it's not exponential. Okay, so our between was left was A or B. So which one is it? So both equations have, we start with 5,000. That makes sense, right? We start with 5,000 sheets of paper. And then we're subtracting, is it 20M or are we subtracting 75M? So here we have to figure out the slope. All right, so the slope in this case represent M is the number of minutes. So the slope must be the number of sheets of paper that we use per minute. Okay, that's the rate. So here, what we can do is we can say in 20 minutes, you use 30% of the paper. All right, how many sheets will be 30% of the paper? So here we have to do a little calculation here. All right, so we have 5,000, and then that 30% that we use, so we can do 5,000 times 30%, okay, which is same as 5,000 times 0.3, and that should give us 1,500, okay? So in 20 minutes, we used 1,500 sheets of paper. So that's how many sheets of paper per minute? Well, then we can do 1,500 divided by 20. That should give us the number of sheets paper that we use per each minute. Okay, 1,500 divided by 20, we get 75. Okay, so 75 sheets per minute. Okay, so the slope should be negative 75 because we're getting less and less, right? We're using up paper. So the number of pages remaining, okay, will get less and less. So it should be negative slope. Okay, so it should be negative 75 because we're actually using 75 sheets of paper per minute. Okay, and that should be our final answer for number 29.